third way that boys and girls have learned how to multiply two-digit by two-digit multiplication problems. This is called Lattice. Most of you probably have not heard of it. The boys and girls seem to enjoy it. So we're going to do 56 times 34. And the first thing that we're going to do is we're going to draw a square. And because it's two-digit by two-digit, we're going to make a grid that's 2 by 2, meaning 2 rows and 2 columns. And then we're going to take the first factor and we're going to put it on our width dimension, which is 56. What's different about the lattice is that we don't split these up by place value. Okay, so we're not going to do the 50 and the 6 this time. We're just going to do the 5 and the 6 and the 3 and the 4 across the top. Okay? The next thing that we're going to do is we're going to put in our lattice. Of course, we call it lattice because it's similar to a lattice fence. And these lines are important. They go at an angle. And they're important because that's how we're going to be adding. We're going to be adding in this lattice section inside the box. So the first thing that we're going to do is we're going to do exactly what we did with our area model.
Allison Morris, please call the front office.
We're going to multiply 5 times 3. 5 times 3 is 15. So I have this box to put it in. I'm going to put 1 and 5. 5 times 3, 15. Then I'm going to go to this box, and it's going to be 5 times 4, which is 20. 2 and 0. 3 times 6, which is 18. And 6 times 4, which is 24. Now I want to mention that if you have a problem like 2 times 3, which is 6, you're going to put a 0 here and the 6 in the bottom. Okay, so there'll be 0 10s and 6 1s. Now that we've filled in our box, we're going to do the addition portion. So this row, this portion, is our 1s. This row is our 10s. This row is our hundreds. And our thousands are down that direction. So we're going to look inside the box, make sure that you don't add anything out here on the outside. And some of the kids will actually stretch these out like that. And how many 1s do we have? We have 4. How many 10s do we have? We have a 0, we have 2, and 8. 8 plus 2 is 10. Well, when we normally add 8 plus 2, in a traditional algorithm, we put the 0 and we carry the 1, as we call it, or we regroup. So that's going to go up to our hundreds. So now I had a 1, a 5, and a 2, and this one here, don't add the 6. 5 plus 1 is 6. 7, 8, 9, make sure you don't add the 4. So we have 9 hundreds. And I have how many thousands? Only inside the square, inside the large square, I have 1. And of course, my answer is 1,904.